Today we're going to talk about the effect that B has on the sine and cosine graph. B is the frequency. First of all, let's start out with an example. Y is equal to, we'll do negative cosine of 2x. And we won't put anything else on there yet, but we'll add a couple of other transformations after we get done with this. So the amplitude is 1. The frequency is 2. And the period is 2 pi over b, 2 pi over 2, which is pi. And remember, period is the horizontal distance from start to end. Hopefully you can see this. And so if I wanted to graph this, I'd start out with my horizontal axis. And I'd start out with the 5 major points, start with the first and last, divide it up into half, and then divide it in half again. Since the period is pi, I'll start at 0 and end at pi. And then halfway between 0 and pi is pi over 2. And halfway between 0 and a half is a fourth. So this would be a fourth pi. And halfway between 1/2 and 1 is 3/4. So this would be 3 pi over 4. If this is a negative cosine curve, you're going to start down at the minimum point, go up through the x-axis. Up here would be your maximum point. Here's your midline again, and then you'd end down here. So we'd have a concave up graph, followed by concave down, and then concave up. And so that's just a negative cosine of 2x graph with the very important x values that are put on the horizontal axis. Well, what if we wanted to say, oh, we'll do this plus 5 on the end? The cosine of 2x is in its own set of parentheses. So all that means is we're going to shift this vertically up 5. So this, instead of being the x-axis, this will be the line y equals 5. So that's pretty easy. And then the last thing we're going to do is I'm going to put a 3 in front of this cosine. So we'll do negative 3 cosine of 2x. So now the amplitude, instead of a 1, it's equal to 3. And what that means is the distance between the midline and the top is 3. So if this line is 5, then this maximum y value will be 8. So this particular point right here will be pi over 2, comma 8. This minimum point right here would be 0, comma 5 minus 3 is 2. And then this point right here would be pi, comma 2. And since those y values are still above the x-axis, they're positive, then what we could do is we could draw an x-axis in here, make it a little longer than the y equals 5 line. So here is our x-axis, and our y-axis is right here where x equals 0, so we could draw our y-axis in here if we wanted to. So this whole cosine curve would be totally above the x-axis, 2 units above, starting 2 units and ending 8 units above. And so that would be adding an a b, and a d value. And my last example, I'll put a c value. I'll put a horizontal shift in. Let's do another one. Let's do y is equal to, oh, we'll do negative. I'll leave a blank in here because I'm going to put a number in, but not at first. I'll do negative sine of 1/3 x. Or this could say negative sine of x over 3. And I'll also put a vertical shift in there like I did last time, but we'll just start out with negative sine of 1/3 x. So we'll draw our horizontal axis. Now in this problem, the amplitude is 1 for right now. We're going to change it in a minute. But the most important thing right now is the frequency. The frequency is 1/3, the b value, which makes the period 2 pi over 1/3. 2 pi over 1/3 is 2 pi times 3, which is 6 pi. And so between the start and the finish, we have 6 pi. So we'll label some important points on our x-axis. We'll start here, we'll end here, divide it up halfway, halfway, halfway. So we're going from 0 to 6 pi now. Half of 6 is 3, and half of 3 is 3/2. And half of 9, 6 pi plus 3 pi is 9 pi. Half of 9 pi is 9 pi over 2. So there are the important x values. A negative sine curve starts at the midline, comes down first, hits the midline, goes up, and hits the midline. So we have a concave up graph in the first half of it. So you draw your little bowl, and then we have a concave down part of the graph in the second half. So there's your negative sine of 1/3 x with those important x values. Now let's tack on a vertical shift. Let's do -3. So this will be y is equal to -3. So we're underneath the x-axis right now. Let's put an amplitude on. Let's put an amplitude of 4. So we'll mark the amplitude is equal to 4. So the distance between here and here is 4. Here and here is 4. So if I start at -3 and subtract 4, we're going to get a -7. So this particular point has coordinates 3 pi over 2, -7. This is on, all these are the y values of 3. And this point right here is -3 plus 4, which is 1. So this point over here would be 9 pi over 2, comma 1. Now this would actually be above the x-axis, just a little bit above. And now if we want to draw our x-axis in, make it a little longer than that midline. So here's our x-axis. And our y-axis is at x equals 0. So this curve is mostly below the x-axis, but it goes up and goes a little bit above the x-axis here. All right, so now we've again added an a and b and a c. The last example I'm going to give you has both a b and a c value. So this one's the trickiest of all. We will graph y is equal to sine. And now watch this these sets of parentheses. You're going to open up one set of parentheses and put the b value in. I'll have a b value of 3. Then open up another set of parentheses and have x minus, and the c value, I'll give you pi over 2. This is going to make the math a little bit tricky, but I think you can handle it if you just remember your fraction. These are the only transformations that we're going to do on the sine curve. I'm not going to put an amplitude. I'm not going to put a vertical shift on it. So this is going to be it for this, this sine curve. So we'll write off to the side here, the amplitude of this is 1. Now the period is 2 pi over b, and b is 3. So this period is 2 pi over 3. And you might want to put a note here that the b is on the outside of this set of parentheses. if this b were distributed, it would be 3x minus 3 pi over 2, and you'll see in the end that this is actually a shift to the right of pi over 2. If you were to distribute the 3, it would kind of look like this were a shift of 3 pi over 2 to the right, but it's not. So what you want to do is you want to make x on the inside of the parentheses have a coefficient of 1. So if there's any other coefficient, you want to move it to the outside, and you need to factor that if you have to. But in general, this is going to be the format of the sine cosine function. You're going to have b outside of the parentheses, and then you're going to have the horizontal shift, which is inside of the parentheses. So what this means is we're going to be shifting this to the right by pi over 2, but we're not going to do that until the end. We're going to set up our sine curve with a period of 2 pi over 3. That's our first job. After we get the sine curve set up, then we can do the shift. So I'll just set up my horizontal axis. Now I told you that this is not going to be shifted up or down, so we can actually make this the x-axis or the line y equals 0. And we'll divide this up into 2 halves and then 4 quarters. So if there were no horizontal shift, that's how I'm going to set it up first, imagining that there's no horizontal shift. So if there's no horizontal shift, this would start at 0. The period is 2 pi over 3, so my right end point is 2 pi over 3. Then I'm going to get half of this distance. Well, half of between 0 and 2 pi over 3 is 1 pi over 3. Zoom in a little bit on this. And then half the distance between 0 and 1/3 is 1/6. You can just divide that by 2, which is just multiplying by a half. So this is pi over 6. And then if you add these two together, pi over 3 plus 2 pi over 3 is 3 pi over 3, which is just pi. And halfway in between these two is pi over 2. So these would be the x values of this function with a period of 2/3 if it hasn't been shifted to the right or to the left. So that's your first job, to set that up. Now the second job that you have is to take care of this shift to the right by pi over 2. So you're going to, just like we did in class, you're going to take each one of these x values and you're going to add pi over 2 to them. And then we'll get our new x values, and then we can figure out where the y-axis goes. We already know that this is the x-axis here, but our y-axis is going to be somewhere over here. So you might want to shut off the video and see if when you add pi over 2 to each one of these x values, if you get the same values that I do. So you can shut this off temporarily and then turn it back on. So 0 plus pi over 2 is pi over 2. Pi over 6 plus pi over 2 is like adding 1/2 plus 1/6. If we add 1/2 plus 1/6, we're going to get 2/3. So this is 2 pi over 3. You need to be able to do this math without a calculator, obviously. The next one is pi over 3. If you add pi over 3 plus pi over 2, it's like adding 1/3 plus 1/2. 1/3 plus 1/2 is 5/6. So this would turn into 5 pi over 6. The next one is pi over 2. Well, pi over 2 plus pi over 2 is just 1 pi. And 2/3 plus 1/2 is 7/6. So this becomes 7 pi over 6. So these are the true x values of our shifted and compressed sine curve. So what we can do is we can just graph a simple sine curve. Starts at the middle. The amplitude is 1, so you're going to go up 1, go to the middle, go down 1, and then end here. So there's your sine curve. The distance between each one of these x values, if you subtract 2/3 minus 1/2, you're going to get a 6. So each one of these tick marks on the x-axis is 1 pi over 6. We've added pi over 6 every time to get to the next x value. So if we want to go back and find out where the y-axis is, we can subtract pi over 6, or 1/2 minus 1/6, and you're going to get 1/3. So this is pi over 3. 1/3 minus 1/6 is 1/6, so this is going to be pi over 6. And then the y-axis actually goes right here at the very beginning here. I'm going to show you this because we're going to look at our graphing calculator and we're going to change the tick mark values on it. So you might want to grab your graphing calculator also. So here we go. Here's our beautiful sine curve. And if we want to continue all the way back to the y-axis, we just have to go down and hit the minimum on the next point, go down and hit the x-axis on our next point, and then we're going to go hit the maximum right here. So the y-intercept happens to be 1. So this actually is a cosine curve, what we've just graphed. But we'll call it sine of 3x minus pi over 2. So now what we're going to do is we're going to put this in our graphing calculator. We're going to set up our window so that we can actually see exactly what we've graphed. And we're going to set up our tick marks so that there's 1 tick mark for every pi over 6 that we put on this x-axis. So grab your graphing calculator and enter sine, opens up parentheses automatically, 3 parentheses x minus pi over 2. Excuse me. Last year, probably when you were in Algebra 2, your teacher taught you to do zoom 7, which is zoom trig, which is a nice sine curve, but that's not exactly what we graphed. What I'd really like to see is exactly what we graphed. Hopefully this won't be too blurry. Well, it looks a little blurry. I'll come back a little bit. So in order to set up our window correctly, it looked like we wanted to set our x min at 0, and our x max was 7 pi over 6, so I'm just going to type in 7 pi divided by 6. It's going to convert it to a decimal, but that was the value of 7 pi over 6. And the scale on my x-axis, every tick mark that I had on my graph was pi over 6. So I'm going to plug in pi over 6 so I can see each tick mark. And the y min and max can be anything kind of small. You can make this, maybe we'll make this -2 up to +2, so we can get a pretty good look at this. And the scale on our y-axis will be 1. So now when we graph this, we should get graphed exactly what we have on our paper. Every tick mark is pi over 6. So you got pi over 6 and pi over 3 and pi over 2. This is where we started our graph when we first started it out. And here's 2 pi over 3, 5 pi over 6, here's x equals pi, and at the very end is x equals pi over 7. And it starts up at 1, ends down at 1. This is actually kind of like a cosine curve, but it's been shifted to the right. And this, like I said, this point right here is pi over 2, so this has actually been shifted to the right by pi over 2. That's why we take the 3 outside of the parentheses when we want to find out what our horizontal shift is. So I think that's enough for today, and you'll get practiced at graphing with some various b values and various c values together, separately and together. And if you ever want to try any of these on your own, you can make up your own sine and cosine functions, put a value of b in if you'd like, put a value of c in if you'd like. If you want an amplitude or a vertical shift on the end, you can do that. And then you can always check your answer by plugging it into y equals, changing your window if you need to, and changing the tick marks on your x-axis so that it would be scaled correctly. So that's it today.